Welcome everyone. So in this video, I want to work out this problem with you. If two fair dice are rolled, find the probability that the sum of the dice is 8, given that the sum is greater than 3. So that's a conditional probability example. Now, before I dive into this problem, let me give you what the conditional probability formula is. So we know that the probability of A given B, where B is the condition we're putting on, is equal to the probability of A and B divided by the probability of B. So hopefully you know this formula by now. I'm just going to go ahead and dive into the problem. So when you toss two fair dice, you know the sample space will have 36 sample points. So your sample space has 36 outcomes. So I'm going to go ahead and list them for you so that way you see what are the possible outcomes. So 2 dice, which means I will create a table for it. So 1, 2, 3, 4, 5, and 6. So let's suppose that's our first die and these are the outcomes. And the second die, we're going to list them horizontally. So let's call it, so let me just try to make it straight. So 1, 2, 3, 4, 5, and 6. So there you have, I list the outcomes this way. Now I'm going to pair each outputs in the following way. So let's suppose the first you get a 1 and the second die you also get a 1, right, like that. And then first die you get a 2, second die you get a 1. Third you get 3 and then 1 on the second, or you can get a 4 on the first, 1 on the second, or 5 on the first, 1 on the second, or 6 on the first, 1 on the second. And you just continue to fill out every box in this fashion. Let's fill out the second one now. So I can get 1 on the first, 2 on the second, or 2 on the first, 2 on the second, or 3 on the first, 2 on the second, 4 on the first, 2 on the second, 5 on the first, 2 on the second, 6, and 2. Continuing on, I can get 1 on the first die and 3 on the second, or 2 on the first, 3 on the second, 3, 3, 4, 3, 5, 3, 6, 3. Or we can get 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4. Almost there. So we have 1, 5, 2, 5, 3, sorry, not 3. Yeah, 3, 5, 4, 5, 5, 5, 6, 5. And the last option we get 1 on the first, 6 on the second, 2 on the first, 6 on the second, 3 on the first, 6 on the second, 4 on the first, 6 on the second, 5 on the first, 6 on the second, or 6 on the first, 6 on the second. So this is the list of possible outcomes. Now we can answer the problem. So it's pretty large sample space. So we want to find the probability that the sum of the dice is given. So you always want to write down the given statement first. So we're given that the sum is greater than 3. Okay, so let's check out where the sum is greater than 3. The sum is greater than 3 right here, and right here. So along this diagonal and anything below, the sum is greater than 3. So all of these will have the sum to be greater than 3. So let's count how many of those. So the best way to do that is to simply remove the ones that are less than 3. So I know that this one is less than 3, this one is less than 3, this one less than 3. So out of the 36 outcomes, 3 are less than 3. So the sum is less than 3. So the probability that the sum is greater than 3 is same as doing 1 minus the probability the sum is less than or equal to 3. So that's going to be 1 minus. Where is the sum less than or equal to 3? Well, that's 1, 2, 3. So that's 3 out of 36 outcomes. And that would give us 33 out of 36. So that's the probability the sum is greater than 3. And you can count all of them if you want to, but I think this is better way, convenient to do it. So I got that. Now I need to find the probability that the sum of the dice is 8. Where is the sum that happens to be 8? So we know the sum is 8 right here, and then right here, and right here, right here, and right here. So this is the outcome for sum to be 8. So we know the probability the sum is 8. That's going to be how many? That's 5 of those out of the 36 possible outcomes. And now we're ready to kind of work it out. So we are looking for, let's define events. So probability that the sum is 8 given that the sum is greater than 3. So we're looking for probability that the sum is 8 and the sum is greater than 3 divided by the probability that the sum is greater than 3. Okay, so I didn't really introduce A and B to define my events. I just put them in a symbolic way, but hopefully you introduce them to make it simpler for yourself. So what's this probability? So I'm looking for the intersection of these two. So I want to know what's the probability that the sum is 8 and it's greater than 3. Well, that's only this one right here. So it happens to be only this part. So that's only because it's 8 and it's greater than 3. So that's going to be only 5 out of the 36 outcomes. So we have 5 out of 36. What's the probability it's greater than 3, the sum? Well, we know that that's all of these below. So, and we counted that to be 33 out of 36. So that's the one for denominator. And this will simplify to 5 out of 33.